So earlier we've talked about how matter can be made up of pure substances or mixtures. And in this chapter we're going to go into detail about pure substances. And pure substances can either be elements or they can be compounds, right? And compounds are just a mixture of elements in a set repeating ratio. Elements here are going to be subdivided one more time. Elements can either be atomic or they can be molecular. And our atomic elements are usually found as single atoms right off the periodic table, like our mercury or our neon. Our molecular elements are, on the other hand, usually are diatomic, which means they have multi-atom molecules. There's two atoms for every molecule, but two of the same atom. Okay, that's why they're called molecular elements, because they're two of the same elements, like nitrogen or oxygen. And we've learned the rule of 7 because there's 7 diatomic molecules on the periodic table. You start with the nitrogen atom, which has the atomic number 7, and then you make a 7 figure to include the halogens as well, and then you add hydrogen. And so this will help you memorize which elements on the periodic table exist as molecular elements, and they're found in nature as N2 or O2. You would never really find nitrogen alone or oxygen alone. They're very reactive, so they always have to exist as diatomics. Now let's talk about compounds. Compounds can be further split into molecular compounds, and we have ionic compounds. Now the molecular compounds are made up of 2 nonmetals. Okay, and the smallest unit is called a molecule for molecular compounds. Ionic compounds are made up of metal and nonmetal. So they are made up of cations, which are positively charged, and anions, which are negatively charged. Okay? And they are usually structured in a 3-dimensional array of cations and anions that are made of formula units. So the smallest unit is the formula unit for ionic compound. Now let's learn to classify each substance as an atomic element, molecular compound, or ionic compound. This whole time I want you to have a visual of the flow chart that we just made. Okay, so the first example is krypton, which is Kr. And Kr is found on the periodic table, so it's an element, and it's not one of our 7 diatomic elements, so it is an atomic element. Cobalt chloride. Cobalt is on the left side of the periodic table, so it is a metal, and chlorine is on the right side, so it's a nonmetal. So that will tell us it's a compound, because first it has 2 different elements in it. That tells us it's a compound. And now that we have a metal and a nonmetal, this gives us that it's an ionic compound. Nitrogen is found on the periodic table, so it's an element, but it's one of our diatomics, so it is a molecular element. SO2 is made up of 2 different elements, so that will tell us it's a compound, right? But they're both nonmetals. So in that case, it's going to be a molecular compound. Because remember, molecular element is just made up of the same element twice. but a molecular compound has two different elements in it, two or more different elements. Okay, for E, we have three different elements, so that tells us it's a compound, but we know that we have a metal, which is potassium, and we have our nitrate group, our polyatomic ion, which is a nonmetal, so it's going to be ionic compound. Okay, go ahead and try this on your own. And we want to again classify each substance as an atomic element, molecular compound, or ionic compound. Again, keep that flow chart in your mind as you're classifying these. The first one is chlorine. Chlorine is found on the periodic table, but remember it's one of our diatomic elements, so it is a molecular element. NO is got two different elements in it, so it's a compound. And let us ask ourselves, are they both metals? Are they metal, nonmetal, or both nonmetals? It looks like they're both nonmetals, so it's going to be a molecular compound this time. Don't forget to put compound. Okay. AU is the symbol for gold. So gold is found as on our periodic table, and it comes as a single atom. So it's going to be an atomic element. We have here sodium and oxygen. Obviously, there's two elements, so it's going to be a compound. And now we need to ask ourselves, which kind of compound is it? We have a metal and a nonmetal, so it's going to be ionic compound. In E, we have chromium and we have chlorine. And we need to ask, obviously, this is a compound. It's got two or more elements in it. So which kind of compound is it? Well, chromium is a metal and chlorine is a nonmetal. So again, it's an ionic compound.